This example is like problem 13 in the exam 3 review. We are performing a hypothesis test of mean equals 25 against mean less than 25. We have a sample size here of n equals 60. Our sample mean for that sample of 60 was 24, and population standard deviation is 4. So we are given the population standard deviation. That tells us that we're going to be using the z distribution, normal distribution. If we had been given S, the sample standard deviation, then we would use T, the T distribution. So they say compute the value of the test statistic Z. So that's this formula here, sample mean minus hypothesized mean over standard deviation of the sampling distribution. So that's 24 minus 25, and we are dividing by 4 over square root of 60. So let's compute that real quick. So I'm going to use horizontal fraction so I don't have to use parentheses here. So 24 minus 25, and on the bottom 4 divided by square root 60, and we get 1.936, so 1.94 negative. Now you can also get that with stat test z-test. Do that real quick. So stat test z-test is the first one. Press enter. We are going to use the summary statistics, so highlight that. Our hypothesized mean is 25. The standard deviation was 4. Our x-bar is 24. Our sample size is 60. And then it's already set for a less than mu0. So we're going to come down here, and if we draw instead of calculate, it'll actually show us that this is a left-tailed distribution. So our test statistic, negative 1.936, that's what we got before. And it also tells us a p-value, 0.0264, which is less than 0.05. And there is that z is negative 1.936, and there's our p-value. So they want to know, is the null hypothesis rejected when alpha is 0.01 and 0.05? So first, choose the correct type of test of hypothesis, and find the critical values for 0.01 and 0.05. We're rounding to 3 decimal places. So this is a left-tailed test. Remember here that less than is left, greater than is right, and not equal is two-tailed. So this is left-tailed. So our critical value for alpha is 0.01. If you have a left tail, then your rejection region is on the left. So if alpha is 0.01, then this area right here would be 0.01, so left area 0.01. So we would use inverse norm and 0.01 to the left. So our critical value here is going to be inverse norm of 0.01. Let's go ahead and do that real quick. So second variables to get to the distribution menu. 3 is inverse norm. We want 0.99. We're leaving mean standard deviation at 0.01 because we're dealing with z-values. So 2.326. And, oh, sorry, we did 0.99 to the left. Second variables, inverse norm. Our left area is 0.01, not 0.99. And paste it, enter. So we actually get the negative. So this would be for a right-tailed test, and left-tailed it'll be negative. So negative 2.236. And then for alpha is 0.05, we'll do the same thing, inverse norm, but with 0.05. So second variables, inverse norm, and 0.05. negative 1.645. And now we want to determine whether to reject the null hypothesis. So we compare our test statistic to the critical value. So our test statistic of negative 1.94. So this is our critical value for, let's see, alpha is 0.01. This will be negative 2.236. And our test statistic is negative 1.94, which is to the right. So here is our test statistic, negative 1.94. It is not in the rejection region. So that's the reject H0 region. So since the test statistic negative 1.94 is not in the critical region or rejection region, we do not reject H0. At the alpha 0.01 level. And then at 0.05, now this negative 2.236 changes to a negative 1.645. And now the negative 1.94 is more negative, so it's going to be over here instead. And so now it is in the rejection region. So since the test statistic here, no, we've still got a test statistic of negative 1.94. Test statistic doesn't change. It's the critical region that changes. And that is in the critical region, so we reject H0 at the alpha is 0.05 level. So remember, the test statistic is measuring how extreme the sample is. So a bigger negative would be a more extreme sample, and this is, compared to our probability of type 1 error, the cutoff for that rejection region, negative 1.645, this is more extreme than the cutoff for the rejection region. So that's why we reject H0. Oh, and I just realized here I've got the 2 and the 3 switch. That should be 326, not 236. We still do not reject. For alpha is 0.01. So it doesn't make a difference in the conclusion.